Good evening, everyone. I wanted to go over what's called right now 96L. It's a invest that the National Hurricane Center has out in the Mid Atlantic. It's at let's see where it's at. 11.6 north and 45.8 west. Current speed is 30 knots sustained, and it's forecasted to be what looks like the next monster. And as much as I hate to say that, it's the truth. I saw this 2 days ago on the GFS and NavGem runs. I didn't say anything at first because I thought it was the models just being the models, but apparently not. But you can see that this right here, what I have, the little contour lines, that would be, that's convergence at the surface. And I'm not sure what that's measured in. It just says 10. It doesn't say over here. But anyways, what looks good for this, well, deadly, I guess I should say, is that it has a nice amount of convergence at the surface right here in this area, and not so much right here. And that's usually what you want to see ahead of a tropical wave. That's nice and elongated. That looks kind of like this. That would be where this tropical wave is, and I'll pull up the surface analysis here in a second. But why that's a good thing is because you have the convergence. Let's see, here's the surface. It's more like a cross section more than anything. And here's 200 millibars. So what happens is that the convergence at the surface goes up to the top because winds collide here at the surface and they get to the top of the atmosphere and they diverge like that. And then once they diverge, it creates subsidence ahead and behind the tropical wave, and that's a factor of determining its strength. And you can tell right here where it says -5, and you can see good outflow right here where there's shear. I'm not shear, excuse me. I'm tired. Cirrus clouds right here. Let's see. If I click 8 kilometers, I'm not going to do that because the loop will stop, but that's okay. I'll do it anyway. Oops. You can tell that over here with Jose, that's the case. See these -5s right here, and there should be one here, but there's not. And I'm not going to go over Jose because even though his track is important, because a lot of the models show Jose kind of doing this number going up towards very close to the New England coast, by the way. And I think it'll make landfall, but that's besides the point. All the models agreed that he's going to go down and kind of do this another loop in his lifetime. That might have an impact on where this guy down here is going to go. And he's forecasted to kind of make his trek across the Lesser Antilles. And then I guess the influence from what used to be Jose kind of catches this guy and he goes up across and towards the Bahamas. But now we can look at some model analysis. This is a infrared water vapor difference, and I'm not sure what it really measures. It measures in something in degrees Celsius, but clouds, no, that's what that is. Okay. See, there's nothing I want to look at on there. Okay, so here's what the National Hurricane Center has right now. It's at 90% and it's at for the next 48 hours and over the next 5 days, and it's forecast to move westward or northwestward towards the Lesser Antilles of the Caribbean at 20 miles an hour. So this thing is booking it, and that's evident on the surface analysis they have right here. And what you like to see with a strong tropical cyclone. I'm gonna use black. Okay, so this one, notice how the arrow is really short and slow. That means that it's gonna soak up all that heat in the ocean that it expels as latent heat in the upper atmosphere. And if you didn't know, a hurricane's pretty much like a diesel engine, except backwards. Diesel engines work off of adiabatic compression, no spark plugs, and combust the air fuel mixture like that. And hurricanes pretty much do the exact opposite. So this one's, since it's moving fast, it's has a lot of potential to collect the warm ocean waters. Actually, there was something I wanted to look at on that other side. Let's see. Nope, nope. Where was I? Okay, right here. Is it? Nope. So, I guess we have to go back here. No, it's on here. I guess I'm blind. It's not. Okay, that's alright. Okay. So, here's the sea surface temperatures. I could have swore I saw this. But anyway, you can tell that the the ocean temperatures down there are very warm. And I really don't like that. That's not a good depiction of what I'm wanting to show you guys. Nope, that's not it either. Okay, I'm back. I got what I wanted now from a NASA site. So here's your sea surface temperatures, and as you can tell, the temperatures down here range from, you take my word for it, but I'll post this later if you want it that badly. Right here, this is 30 to 32. All throughout here, this is 28 to 30 right here in the yellow. More 30 to 32 right here. So you can tell that, and I guess it's not the case, is that usually the Gulf is a lot hotter, and I guess because of Harvey and Irma it's not. But the path that this invest is taking, which is oops, right about here right now, is where the invest is, and the path it's taking over this part of the Caribbean is definitely full of hot water. And where this other one is, this tropical depression that's forecasted to, this guy is forecasted to go somewhere up here. He's going to catch this mid-latitude trough coming down like that. So he'll have no impact on anything, maybe Azores out here. But you can tell that the sea surface temperatures right here, this is not what you want for a hurricane formation at all. That is way too cold. But this one right here, 96L, has plenty of warm waters to fuel off of. Alright, now that that's out of the way, I paused the video so I forgot where I was. But here's the NavGem. This is what I really like to use as far as hurricane long-range models go, because they have a lot of good products. And low to mid tropospheric precipitable water, excuse me, and flow. This is where you want to. This is what you want to use to watch how your hurricanes or tropical cyclones invest, whatever you want to call it, how they steer throughout the atmosphere. And so you can tell that that one that I just talked about is going up there. See, but what's steering this guy right here and keeping him towards the south, towards the equator. So there's a high, there's high pressure right here, a subtropical high, and flows that way, flows clockwise, clockwise. And these guys don't like to go towards high pressure because that just doesn't make sense. So he'll be, staying down low. So the placement of, and there's another high over the Gulf as well. And the track of Jose, which is forecasted to do something like this, again, he's going to make another loop, has a big impact on where this guy right here, which by now in this model should be a hurricane. And let's see. Let's watch how it evolves. So I originally thought when I was looking at the models that, and apparently that's not the case, that this guy would go up and he would kind of catch this breakdown in the subtropical ridge. You can see it right here, and again right here. And these are streamlines. You want to use streamlines in the tropics due to the fact that Coriolis effect doesn't, or force, it doesn't take place until you're 5 north or south degrees away from the equator. And it gets stronger as you go in towards the north or south of the equator. And that's due to the fact that the Earth is in fact round. Yes, it is round. My God. Is that ever a question? Apparently it is. But anyway, so it looks like this, you're going to see part of the subtropical ridge. It's going to, a piece of it's right here, and another piece of it it's kind of sticking its leg in between, I guess, the door that this thing, this is our only chance for this not to affect the eastern coast of the United States right here. If it doesn't catch the little break in the ridge right here, then this thing has nowhere else to go but somewhere this way. After about this point in the model, this is 180 hours out. I mean, who really knows? But the fact that it's this close, I mean, let's face it, this guy is going over the people who already had a Category 5 hurricane blow everything they had off the island completely. Like, if you look at the satellite images of before and after Irma, before this, the islands were green, and then after they were literally brown to gray. It was this is going to be devastating if it doesn't catch this little break in the ridge right here. Say 700 millibars is the best bet for watching how your hurricane moves, and also it's good for intensity if you have a good deep layer moisture. And yeah, we'll look at some good models for that deep layer moisture. But so, and I hate to scare everyone here. If you're from Florida, you probably already are scared. But there's Jose right there, and that's how awful close he gets to the New England coast. My friends in Atlanta probably thrilled over that because they don't like Tom Brady, but I digress. Okay, so, and I guess he kind of does catch the break in that subtropical ridge, but by the time it does catch the break, look, it doesn't have anywhere else to go because that ridge, according to the GFS, is going to build right here. That's where your ridge is. and this is kind of where you see the subtropical and the mid latitudes, the ridging, they morph together. So I think the biggest two things to worry about with is as far as where this hurricane right here is going to go, is the placement of this mid latitude trough, the placement of this high right here, and so this guy is going to want to go towards this trough. Fact. Scientific fact. And if this ridge is chilling, like the GFS says it is, then it's not going anywhere. But I really like this model. It's what the National Hurricane Center uses as far as their constant input model. But here's the infrared satellite. So this is about now, and watch how fast it blows up. Yeah, I'd say right here is the moment is where it would go through an eyewall replacement cycle. This thing for sure is going to go through an eyewall replacement cycle at one point in time before it gets even anywhere close at all to the coast of New Invest. Cool. I love hurricane season. But it's, the strength of this, the path, it's all questionable at this point for sure. Like, this is way too far out, and this is what 216 hours out on the GFS. But regardless, I mean, no one wants to see this right here, where these guys literally just got devastated by Irma, and Irma went up through this way. They didn't even get the worst Irma, like Naples did. So, from the Savannah area right here, all the way down to, I'd say, Flagler, maybe Daytona area right there. It's terrible. But yeah, I'm at 17 minutes now, so I'm gonna cut this off. If I have any more information, I will. I'll be making another video. All right. Thanks for watching, guys. You have a good one.